Welcome students to online classes of mathematics for class 9th. In this video we are going to study the chapter number 10, which is the circles of NCERT textbook, and we will be looking at the exercise 10.2. This one is the session number 2 for this particular chapter. Myself Deepak Gautam, TGT Mathematics in Kendriya Vidyalaya Sangathan. So let's start with our today's class. The chapter 10 circle is divided into total 8 subtopics, out of which we have already covered the first 2 subtopics in the previous session. Now in this session we will be looking particularly at the third subtopic, which is angle subtended by the chords at a point. Okay, angle subtended by a chord at a point. So let's start with the part 3, angle subtended by a chord at a point. Suppose we have a circle with center O and we have a chord. Let's draw a chord in this circle. Let's name a point A here and a point B here. Once we join these 2 points, what we get is, after joining the points, we'll get a chord AB for this circle. So once we draw a chord in a circle, that chord can make 3 types of angle in that circle. So one, that be the angle if we join the end points of the chord to the center. So we'll get an angle like this. We got an angle which is angle AOB, and this angle is at the center, which is made by the chord AB. Okay, we can have another angle. Suppose if we take a point, let's take a point C here, okay, which is on the major arc of the circle. As you know, this bigger part of the circle is called the major arc. Okay, so we have a point in the major arc of the circle. So if we again join the end point of the chord, that is A to C and C to B, we will get an angle which is made by a chord at a point in the major arc of the circle. Okay, so that's the second angle, which is an angle in the major arc of the circle, which is angle ACB. Okay, so if you take any point in the major arc, you will get the angle in the major arc of the circle. And also we can have another point. Let's take one more point in the minor arc of the circle. Okay, and if we join this D to A and B to D, we will get another angle, which will be the angle made by the same chord AB in the minor arc of the circle. Okay, so from here we conclude that if we have a chord in a circle, that chord will make 3 angles. Okay, so right, suppose we have a circle with center O having a chord AB. Okay, so we have a circle with center O having a chord AB. Then this chord will make 3 angles. First one is the angle AOB. This angle is at the center, angle at center. Second, we have angle ACB. This is the angle in the major arc. Major arc of the circle. And we can have another angle, let's say angle ADB, and this angle is in the minor arc of the circle. Is angle in the minor arc of the circle. Okay, so whenever we have a chord, let's in this case AB, that chord will make 3 types of angle. That is the one at the center, second in the major arc, and third in the minor arc of the circle. Okay, so now we'll try to find the relation between the chord and the angle made by the chord at the different part of the circle. Okay, based on this we have a theorem, which is theorem 10.1. This says equal chords of a circle subtends equal angle at the center. Okay, so that means if we have equal chords, okay, so we have more than one chord, they can be 2, 3, 4, 5 and so on. If the chords are equal, they will subtend means make. Okay, so equal chords of a circle make equal angles at the center. Okay, so let's understand this with the help of figure first. So that's a figure in which we have a circle with center O, and this AB and CD are the two equal chords in the circle, and we have to prove that the angles made by these chord, that is angle AOB and angle COD, are of equal measure. Okay, so let's start this proof. First we'll write the given. Given here is a circle with center O, a circle with center O having two equal chords. Okay, so we are given that the chords are of equal method. Okay, so having two equal chords AB and CD. Okay, what we have to prove here is that the angle made by this chord are equal at the center. Okay, that is the angle AOB is equals to angle COD. That's what we have to prove, because these are the angle made by the chords at the center, and it is given that the two chords are equal. Okay, so let's start this proof. It's very simple. We are going to start with the two triangle AOB and COD. Okay, so write in triangles AOB and COD, what we have is, we have in these two triangles we have that we are given that AB is equals to CD. This is given to us in the statement of the theorem that the chords are equal. Okay, and we have this AO and CO will be equal because they are the radius of the same circle. Okay, so we'll write AO will be equals to CO. Reason for this is radii of same circle. That's why these two will be equal. And similarly, the other two sides, this OB and OD, will also be equal. That is, OB will be equals to OD. Again, the region is same. They are the radii of same circle. Okay, so what we got here is we got a side and side. That is, these three corresponding sides of the two triangle are equal. Okay, so we'll write therefore triangle AOB will be congruent to triangle COD. Okay, this is by side congruence rule. Okay, hence the angle AOB will be equals to angle COD. This is by CPCT, that is, corresponding parts of congruent triangle are equal, and this is what we were asked to prove here, that the angles made by the equal chords of a circle at the center are equal. Okay, so that's the proof of theorem 10.1. Now moving ahead to the next theorem. Next theorem is theorem 10.2. This theorem is the converse of theorem 10.1. It says if the angles subtended by the chords of a circle at the center are equal, then the chords are equal. That means in earlier theorem we are given that the chords are equal, then we were asked to prove that the center are equal. Okay, so in that one we were given that the chords were given equal. Okay, then we were proving that the angles at the center made by the chords are equal. Now in theorem 10.3 what we given here is that the angles subtended by the chords are equal, then the chords have to be equal. This is the converse of theorem 10.1. This is 10.1 and this is 10.2. Okay, it says if the angles subtended by the chords of a circle at the center are equal, then the chords are also equal. Okay, you can also do its proof. Let's draw its figure first. Okay, so that's the figure for this theorem. What we have here is that we are given that these angle subtended by the two chords at the center are equal, and we have to prove that these chords equal. Okay, so let's start this proof. First again we'll start with the given part. Given here is again a circle with center O having two chords. Okay, so it has two chords. We are not given that whether they are equal or not. Okay, we have to prove them they are equal. So having two chords AB and CD such that the angle made by this chord at the center are equal, that is angle AOP is equals to angle COD. This is given. Okay, we have to prove here is that the two chords are equal, that is we have to prove AB equals to CD. Okay, so let's start this proof. Again we are going to prove this by proving that these two triangles are congruent. Okay, for that we are going to use side angle side congruence rule. Okay, so let's start. In triangles we are taking is triangle AOP and triangle COD. We have what we have here is, first we have that this side AO is equals to this side AO is equal to side OC. Reason for this one is radii of same circle. Okay, then we have, and angle AOB is given equals to angle COD. This is given in the statement of the theorem, that is the angles obtained by the chords at the center are equal. Okay, so and we have that the OB this side is equals to OD. Okay, so OB is equals to OD. Reason for this one is again radii of same circle. Okay, so with that what we got is, therefore triangle AOB is congruent to triangle COD. This is by side angle side congruence rule. Okay, hence this AB will be equals to CD. This is by CPC. There is corresponding parts of congruent triangle are equal. Okay, and this is what we were asked to prove here, that the chords are equal. Okay, we have proved this, that AB is equals to CD. So if the angles formed by the chord at the center are equal, then the chords will be equal. Okay, so the true theorem is, if the chords are equal, then the angles subtended by them at the center will be equal, that is 10.1 and 10.2 we have. If the angles subtended by the chord at the center are equal, then the chords have to be equal. Okay, based on this we have exercise 10.2. let's now start the exercise 10.2. This exercise again have only two questions. Okay, so we are going to start with the first one. So first question is, recall that the two circles are congruent if they have same radii. Okay, as you know, congruent means the two shape or which are exactly similar or equal in the shape and the size. So the two circles are congruent only if they have the same radii. That means if the radius of the circle are equal, then they will be the congruent circle. Okay, now further we have to prove that equal chords of congruent circle subtend equal angle at the center. This one is exactly similar to the theorem 10.1. Okay, only difference is there we were having two chords in the same circle. Now we'll have one chord in two congruent circle. Okay, so let's first draw its figure. So that's the figure for this question. We have two circle having equal radius, that means their radiuses are same, that means they are the congruent circle. Okay, now we have to prove that the chords of the congruent circle subtend equal at the equal chords. So we have equal chords of congruent circle subtend equal angle at the center. Okay, so let's start its proof. This is answer number 1. Okay, first we'll write the given part. Given here is two circles centers O and O dash. Okay, for this the center is O, and for the second circle the center is O dash. Okay, so we have two circles with center O and O dash having equal chords that is AB is given equals to CD. Okay, so given here is two circles with center O and O dash having equal chords, that is AB equals to CD. Okay, what we have to prove here is that the angles subtended by this chord at the center, that is angle AOB and angle COD, are equal. Okay, to prove here is that angle AOB equals to angle COD. Okay, this is what we have to prove here. Now let's start this proof. Again, this is very simple. Okay, as it is exactly similar to the proof of theorem 10.1. Okay, so we'll start with the two triangle. In triangles which are AOB and COD, we have that first we have that AB is equals to CD. This is given to us. Okay, then we have this side OA is equals to CO dash. Okay, OA will be equals to O dash C because they are the radii of congruent circle. Okay, here we'll not write same circle, we'll write radii of congruent circle. Okay, since they are the radii of congruent circle, so they will be equal. Okay, only then they will be the congruent if the radiuses are equal. And we have this next second side OB equals to O dash D. OB is equals to O dash D. Region is again same, they are the radii of congruent circle. Okay, therefore what we get is that the triangle AOB is congruent to triangle COD. Okay, this is by side congruence rule, by side congruence rule. Okay, so this will implies that this implies this side. Okay, this implies that the angle AOB will be equals to angle CO dash D. Okay, change it to O dash here. Okay, this is O AB and O dash CO dash D. Okay, similarly we are having two triangle AOB and CO dash D. Okay, so this is by CPCT, that is the corresponding parts of congruent triangle are equal. Since we have proved that the triangle OAB and CO dash D are congruent by side congruence rule, so their corresponding part, that is angle AOB and angle CO dash D, will also be equal. Okay, this is what we were asked to prove in the question number 2, that the angles subtended by the equal chords of congruent circle are equal. Okay, so we have proved that the angles subtended by the equal chords of two congruent circle are equal. Okay, this is similar to the theorem 10.1. Question number 2 is prove that if equal chords of congruent circle subtend equal angles at their center, then the chords are equal. So what we have here is, first we have congruent circle, and in which we have chords which are not given whether equal or not, but they are making or subtending equal angle at the center, then we have to prove that the chords are equal. As you can see, this is exactly similar to the theorem 10.2. only difference is here again we have, instead of two equal chords in the same circle, here we have two chords into congruent circles. Okay, so let's first draw its figure. So that's the figure for this question. Again we are having two congruent circle, okay, in which with the center O and O dash we are having two chords A and B, and we have to prove that the chords A and B, AB and CD are equal if the angles subtended by this chord at the center are given equal. Okay, so let's start this proof. First we'll write the answer number 2, then we will write the given portion. Given here is again two circles with centers O and O dash having two chords. Okay, notice that we are not writing two equal chords, we are just writing having two chords AB and CD such that the angles separated by them at the center are equal, that is angle AOB is equals to angle CO dash T. Okay, so what we have to prove here is we are given only two chords, we have to prove them that the given chords AB is equals to CD. Okay, let's start this proof. Again we are going to start with the two triangle, this AOB and CO dash T, and we will try to prove them congruent by using side angle side angle side congruence rule. Okay, so all right, in triangle AOB and triangle CO dash T, we have what we have is that side AO is equals to O dash C because they are the radii of congruent circle. Okay, radii of congruent circles, and angle AOB is given equals to angle CO dash T. This is given in the statement of the theorem, and we have that this OB is equals to O dash T. Okay, again the region is same, radii of congruent circle. Okay, so with this what we get is therefore triangle AOB will be congruent to triangle CO dash T. This is by side angle side congruence rule. Okay, and this implies that the chords AB will be equals to CD because they are the corresponding parts of congruent triangle, that is this is by CBCT. Okay, and this is what we are asked to prove here, that AB equals to CD, which are this chords given in the circle are equal if the angles separated by the chords at the center are equal. Okay, so that's the answer of question number 2 of exercise 10.2. With this we have completed the exercise 10.2. now you have to practice all the question and the theorem multiple times so that you understand them better. Okay, so that's all for now. Thanks for joining here, everyone.